This question asks us to find the distance between the points -2, 7 and 4, 5. So let's visualize those, see where they are. So we need -2, 7. And 4, 5. And if you want to find the distance is the distance from here to here, the shortest distance between the 2 points. But that is actually the third side of a triangle. So I'd like to actually draw that triangle so we can see what that looks like. So the first part of the triangle is here as y goes from 5 to 7. And then we have this part of the triangle, which is y equals 5. And that goes from x goes from -2 to 4. That's the second part of the triangle. So if we're looking at it, this side has length 2, and this side has length 1, 2, 3, 4, 5, 6. So if I'm going to go ahead and draw that triangle on my paper, the change in y is 2, or -2 if you'd like. Change in y is -2, but the length is 2. And the change in x, 1, 2, 3, 4, 5, 6, the change in x is 6. But certainly our length is 2 and our length is 6. So if I draw that triangle 2 here, again, the change in y was -2, so the length is 2. Change in x is 6. Here is the distance. The distance of this is the third side of the triangle. So we know from Pythagoras that's a right triangle. We know a squared plus b squared is c squared. So 2 squared plus 6 squared is c squared. 4 plus 36 is c squared. 40 is c squared. Now c cannot be negative, so I don't need to say plus or minus. So c is just the square root of 40. Let's go ahead and give an exact value there. That's root 4 times root 10. So c is 2 root 10. If you want to approximate it, 2 times the square root of 10 is about 6.32. So that's visualizing a distance as the hypotenuse of a triangle. Now there is a formula that a lot of students like. I always prefer to visualize and try to understand where the formulas come from. I find that easier to remember them. But the formula that they often teach is that the square of the distance is x2 minus x1 squared plus y2 minus y1 squared. Which you'll notice that's just the change in x squared. That's one leg of the triangle squared plus the change in y squared. So we can do it this way. x2, 5 minus 7 squared. That's your change in y squared. Plus y2 minus y1, 4 minus -2 squared. So we get distance squared, 5 minus 7, -2 squared, plus 4 minus -2 is 4 plus 2, which is 6 squared. So we get distance squared is 4 plus 36. Distance squared is 40. So the distance is the square root of 40, as we saw on the previous page, which is root 4 times root 10. So distance is 2 root 10, or as we said also on the previous page, approximately 6.32. But I have to say, yes, you can get it maybe quicker that way. I think there is a big advantage in terms of looking at it as a triangle, and the distance is the length of that hypotenuse. The distance from point to point is just determining that size.